In this video, we will be investigating the giant planets and comparing them to the terrestrial inner planets in the solar system. So first we will investigate the orbits, and so you see now the orbits of Mercury to Mars. Those are the terrestrial planets at the inner part of the solar system. And then the view is expanding outwards to include the orbit of Jupiter, the first of the giant planets, and will extend to include Saturn, Uranus, and Neptune, the 4 giant planets. There are several key differences between the inner and outer planets. The Jovian planets are larger and more massive than the terrestrial planets, and despite this larger size, they have a lower density. This lower density is due to the fact that the composition is different and is dominated by hydrogen and other gases. And so these planets also have ring systems and multiple moons that we'll be investigating as well. So we'll start with the first of the giant planets, Jupiter. This is the most massive giant planet and is 11 times the size of the Earth, if you consider the radius. So the view we see here comes from spacecraft imaging, and you see the distinct features of Jupiter's atmosphere, these zones of different structures, and long persistent storms like the Great Red Spot. Those can be stable over decades to centuries. So we're moving outwards now to investigate 4 of Jupiter's moons, the Galilean moons. The moon sizes have been blown up by a factor of 20 so that you can see them more easily. And notice that the 4 moons have a counter of the orbits on the lower left. And so as we move through the orbits that each moon completes, you'll see a pattern emerging. So the orbital periods are multiples of each other. And for every 2 orbits of that innermost moon Io, Europa will orbit once. And by comparison, for every 4 of Io's orbits, Ganymede will orbit Jupiter only once. And so we can see those patterns emerging from the orbit counter. And so this pattern is very important for providing what is called a resonant pattern in the orbits that induces heating of the moons from tides. So we'll see the full completion of 8 Io orbits, and then by comparison, 4 Europa and 2 Ganymede orbits. So now we'll visit each of the moons individually, starting with Io, that is has most dramatic effect from this tidal heating. So as we look at the view of Io coming from the spacecraft imaging on the right, the day side, and ground-based data sets on the right showing the nighttime. In the night, you see glowing patterns of active volcanoes, and on the day side, you see the deposits of sulfur dioxide that have been spewed out from those volcanoes. Next, we will move on to visit the moon Europa. And Europa, again, has these intriguing surface features, in this case an icy crust and very few craters. So that lack of craters indicates that Europa has a very young surface, and the tidal heating in this case has caused cracks to form in the surface, and it's thought that Europa has a liquid water layer beneath that icy crust. So the next moon we will visit in the Galilean moon system is Ganymede. And Ganymede is larger than the moon in the Earth-Moon system and is also the largest moon in the solar system. So Ganymede is notable for having a magnetic field that was measured by the Galileo spacecraft in its flyby. So the next moon, the 4th of the Galilean moons that we'll visit, is Callisto. And Callisto has a surface marked by many craters, and the moon itself is composed largely of a mixture of rock and ice. Again, we're seeing those spacecraft flyby images of this last of the Galilean moons, Callisto. Next, we will take a view that will give us a broader perspective on the moons of Jupiter. So we'll see first, as a comparison, the Galilean moons, and you see the orbits in the regular pattern, and the moons are also all confined to a plane. As we zoom outwards and we see the additional moons of Jupiter, these are called the irregular moons, and you can notice that their orbits are very different. You see them on elliptical patterns and at many different inclinations. And this is thought to have occurred by a formation mechanism that is different, and that Jupiter is thought to have captured asteroids that would have formed these irregular moons. compared to the Galilean moons that are thought to have formed along with Jupiter.